Hello everyone, and welcome to Unit 3.0 Part 2. This is Mrs. Logus again, and I will be taking you through the rest of Unit 3. And I assure you, this part is not as long as the second part, as I'm sure you can tell by the size of the packet we gave you. So we ended the last unit, or ended the last first part of the unit, with finding theta and evaluating trig functions with the unit circle. But what happens when we don't have an angle on the unit circle? Well, that's when we rely on our calculator. So for instance, if we want to find the sine of 23 degrees isn't a quote-unquote special angle like 30, 60, 45, or 90, so we can use our calculator to help us find our ratios or our angles. So before that though, just a couple reminders with your calculator. In order to find angles on the calculator, you're really finding the inverse. And to do this, you're going to hit second, and then you're going to hit the trig function like second sine, second cosine, second tangent, and then you will get this symbolism in your calculator, something along those lines. What's even more important, though, than how to press that is looking at your mode of your calculator before you start. And notice that's in the directions twice for a reason. If you want to find the sine of 23 degrees, I hope that the calculator is in degrees. It's actually very handy, but I have a online version of this calculator that hopefully will help you see what you need to do to make sure your calculator is in the correct mode. So let's say we wanted to find the sine of 23 degrees. The first thing we'd have to do is press mode. My calculator is already in degrees, but if yours is not, you're going to scroll down until you see the line that hits radian here. And then you're going to scroll over to degrees, press enter. And if that is successfully flashing, then you're going to press clear to get out of that menu. Now that your calculator is in degrees, go ahead and press sine, and then type in 23. Your calculator, you can close the parenthesis if you want, your calculator is knowing that it's in degrees now. If you press enter, remember from the beginning of the unit, when you plug in an angle, you get a ratio out, and a ratio could be written as a decimal. So it looks like my ratio of the sine of 23 is 0.391 according to my calculator. Now if I move to the second example here, cosine of 100, notice that the 100 does not have a degree symbol, which means that I am assuming that it is in radians. So fortunately or unfortunately, that means I need to change the mode in my calculator. So you're going to go back to the mode menu, but this time when you're scrolling down, please make sure that radian is now highlighted. And when that is, please press clear. Now if you press cosine of 100, now the calculator knows you're talking about it in radians. So now if I plug in an angle measure of 100 in radians, my ratio out is 0.862. So that's what I'm going to write here, 0.862. Now it's time for the reciprocal functions, secant and cotangent. Now, first, we have to change our mode back, because notice we're back in degrees. So if I get my calculator back out and I type in mode, let me see if I'm in degrees. Nope. Got to scroll over to degree, press enter, clear. All right, now I'm down for business. Secant of 219 degrees. Now, some of you might be thinking, that has to do with cosine, and I agree. So let's think of it first like we have been. If we found the cosine of 219 degrees first, so in the calculator, if I typed in cosine of 219 degrees, I would get a ratio out of 0.777, I believe. Let me double check that. Yes. Negative 0.777. Let me make sure that negative is apparent. I'm going to make it in a different color. So we know that cosine and secant are reciprocals. So if you wanted to find the secant of 219 degrees, you could then have 1 over negative 0.777. And if you did that in the calculator, take 1 divided by negative 0.777, you should get negative 1.287. for your answer. Now, that way completely makes sense with what we're doing, but some of you might like another way that is a little bit faster. If you look at secant and you know in your head that the reciprocal function to secant is cosine and the reciprocal function to cosine is secant, you could say the following. The secant of 219 degrees equals 1 over the cosine of 219 degrees. And then you can plug that directly into your calculator. 1 divided by the cosine of 219 degrees. And if I do that, I get the same ratio, negative 1.287, but it is a little bit faster. With that idea in mind, if I look at the cotangent of 2, I know that I eventually need to change my calculator back to radians, but I'll do that in a minute. I know that the reciprocal function to cotangent is tangent. So what if we thought about it as that the cotangent of 2 is the same thing as 1 over the tangent of 2. And so if I get my calculator back out, go to mode, go down to radian, great. And if I type in 1 divided by the tangent of 2 in radians, my final ratio out would be negative 4.58. So here I'm going to write negative 0.458. Let me double check that with my calculator. Yes, that's a match. So with all of that calculator stuff in mind, that can help us solve equations in the calculator as well in both degrees and radians. But first, before we find anything in degrees or radians, some of you might be asking yourself, why are these restrictions suddenly here? And so I ask, before we calculate any angles, why are these restrictions necessary when finding an angle? Well, as you know, when you're dealing with a unit circle or a coordinate plane, there are infinite coterminal angles. And so technically, when you're solving an equation, you could keep going forever. You could find angle after angle after angle. So instead of having you write down infinite angles, we restrict it between 0 and 90 and between 0 and pi over 2. Now, why do we restrict it exactly between 0 and 90? Well, if you think about where that is, between 0 and 90 is in the first quadrant. And when we first started talking about reference angles, remember that a reference angle is acute and positive. And so the best place to find a smaller acute angle is in the first quadrant. So something else I'm going to write down here is that we want a positive acute reference angle. And I know I'm being a little bit redundant because reference angle does mean positive and acute, but I'm doing that just to remind you of the definition. So we're restricting it to the first quadrant to make sure that we get that type of angle. So if we move on to the examples and we would like to find the theta value or the angle value when the sine is 3/4. The only way, based on the beginning of the section or the beginning of the chapter, that we could get theta alone is apply the inverse to both sides. So if I write the original problem here, if we apply the inverse sine to both sides of the equation, these cross out, so you have theta equals the inverse sine of the ratio 3/4. So this time I'm plugging in a ratio, which means I'm getting out an angle. So I want to show you on the calculator how you can easily convert between the two. So let's see where my calculator is currently. My mode is in radians. So just because it's easier, I'm going to find radians first. So if I press clear and press second sine, I'm going to get the inverse function. Try that again. Second sine. Not letting me do it. Okay. And then you type in the ratio 3/4. This is your angle in radians. So I'm going to write down theta. Let me check that again. Theta equals 0.848. Theta equals 0.848. Now, if I want to find my radian or want to find my angle in degrees as well, there's actually a nice little trick on the calculator. If you go to mode and then change to degrees first, press enter, and then clear. And then you press second, and then above enter down here, entry. It repeats what you just typed in, but now your calculator's in degrees. So if you press enter again, now you have 48.59 degrees. 48.59 degrees. So these are the answers to my two angles in radians first and then degrees. Pause the video, and I would like you to try this second example on your own. Cosine theta equals 3/5. So treat it like the other example, and I'll be back with you in a bit to check your answer. Okay, so here are my two examples for cosine theta equals 3/5. I took the inverse cosine of both sides, so I had this equation with theta by itself. I actually did degrees first because probably like you, my calculator was in degrees, so I just found it first for the sake of time. And I got 53.13 degrees. And then on the calculator, remember, if you, just like this example I did earlier, if you press second and then entry, you get the same exact thing again, and you could just change the mode. And if you do so, you get 0.927 for your answer. The next one, if anyone tried it by itself, that's wonderful, but what I'd like to do is remind everybody again that if you see one of the trig functions that's a reciprocal, you may want to change it to think about one of the trig functions you're more familiar with, sine, cosine, or tangent. So when I see cotangent of theta equals 3 or 3/1, what I think about then is that the tangent of theta must be equal to the reciprocal, or 1/3. So now tangent of theta equals 1/3. I can take the inverse of both sides. So let me just leave myself a little room here. Let me apply the inverse on both sides. Theta would then be equal to the inverse tangent of 1/3. So ratio in, angle out. So let me see. If I go to my calculator, let me press clear. I currently am in degrees, so that's what I'm going to do first, guys. You might be in a different mode, but I'm going to do degrees first. So if I type in second tangent, it is being a pain, not letting me do this nicely. Second tangent, ooh. There we go. Of the ratio 1/3. My answer in degrees is 18.435. So let me write that down. 18.435 degrees. If I go back to my calculator, go to mode, go down to radian, and then click second entry. There's the same thing again. If you press enter though, now it's in radians, so it would be 0.322 if I'm rounding. So theta would be 0.322 radians. Last but not least, here is an example that reminds me of the very first unit video. You want to draw a triangle based on the situation, and then you want to pick if sine, cosine, or tangent best represents your situation. I again would like you to pause the video, try this one on your own, and I will be back with you with my answer. All right, guys, so to check back in, when I drew my picture, it said that a ramp was 27 feet. So I said the diagonal was 27 because that's the actual ramp. Its platform is 5 feet above the ground, so I said that was my vertical distance. I noticed that I'm trying to find the angle of elevation, which relates to the ground. When I looked at the angle, I noticed I had opposite and hypotenuse, which led me to find the sine equal, or the sine of theta is opposite over hypotenuse. So then I knew that sine of theta was 5/27. I then took the inverse sine of both sides to get theta equals the inverse sine of 5/27. Then in my calculator, when I plug this in radians, my angle was 0.186, and in degrees, my answer was 10.672 degrees. All right, guys, so hopefully this video helped you learn how to use your calculator to find angles in radians and degrees. Thanks.